Example 1. The billing department at a toy company sent out 90 invoices on Monday, 53 invoices on Tuesday, 104 invoices on Wednesday, 40 invoices on Thursday, and 67 invoices on Friday. What is the total number of invoices that were sent out in this 5-day period? So the first thing we want to talk about would be the word clue in here, which tells us which operation to do. It's this word total here that tells me I'm most likely going to have to add. Now, total can also mean to multiply, so we have to be really careful to make sure that we determine whether we should add or multiply. So in this case, since we've got so many numbers, it makes the most sense that we're going to add these numbers. So the operations that I would write on my paper are 90 plus 53 plus 104 plus 40 and plus 67. Now at this point, I could do this manually, but most likely I'm just going to take out a calculator and I'm going to type in 90 plus 53 plus 104 plus 40 plus 67 to get a total of 354. So that makes sense that 354 invoices were sent out. Now, if you were to multiply all those numbers together, because remember, total can mean to add or multiply, you would get a gigantic number, and you would know that that doesn't make sense. Example 2. A new landscape maintenance business requires the below equipment: one rototiller for $599, one gas trimmer for $349, one mower for $469, and one hedge trimmer for $79. What is the total cost of this equipment? So once again, we see this word total, which is going to indicate that we need to add. So I write the operations down that I'm going to do. $599 plus $349 plus $469 plus $79, and I'll do those in my calculator. Now, if you were going to do this manually, you would need to line these numbers up so that the place values are all lined up, so the 79 would stay to the right, and then you could add it manually. I'm going to do it on my calculator. $599 plus $349 plus $469 plus $79 is $1,496. So the total cost of the equipment is $1,496. Example 3. A storage rack at a company contains 3,452 feet of 1-inch stock. On a certain job, 1,966 feet is used. How much is left? So our key word here really are this whole sentence, how much is left? That's going to indicate we need to do subtraction. So I need to take my 3,452 and subtract from that 1,966. Again, if you're doing it manually, you have to make sure you line the numbers up properly. Using my calculator, 3,452 minus 1966, and we get 1,486. So there is 1,486 feet of 1-inch stock left. Example 4. A service department began the day with 768 gallons of coolant. During the day, 72 gallons were used. So look at these words. 72 gallons were used. How many gallons remained at the end of the day? And we've got another set of numbers which say we're going to have to subtract again. How many gallons remain? What is left over we need to find through subtraction. So we'll do 768 subtract 72. Using my calculator, I get 696 gallons remain. Number 5. A plumber receives $73 per hour. How much is she paid for 30 hours of work? Well, in this case, our important words are this per hour. Now, per can mean to divide or multiply. Now, it wouldn't make sense to divide because she's going to get $73 for every one of these 30 hours, so we're going to have to multiply. Now, if we divided those numbers, you'd get an incredibly small value, which would not make sense for 30 hours of work. So 73 times 30 is $2,190. So the plumber is paid $2,190 for 30 hours of work. Example 6. In a home development, cedar shingles are laid to expose 6 inches per course. If 52 courses are needed to cover a surface, how long is the surface? So when you install shingles, you lay out a course like this, okay? And the next course is like this, and they overlap. So something similar to that. So the 6-inch exposure, they're talking about this little bit right in here. That's going to be your 6 inches because this area here is not shown. So if it is 52 courses, so we've got to do this 52 times. So there'd be another row up here. And we've got to do that a total of 52 times. So what we're going to do is we're going to have to, once again, multiply our 6 times 52. And that will get us 312 inches long. Okay, so we would have to keep doing this until this total thing is 52 courses and 312 total inches. Okay. Example 7. A machinist has a piece of bar stock 147 inches long. If she must cut 7 equal pieces, how long will each piece be? Assuming there is no waste, just to get an approximation. So we have this stock, and we need to cut it in 7 pieces. 1, 2, 3, 4, 5, 6. Okay, so pretend that these are all equal. So these are all the same. So we're going to have to divide this bar stock into 7 pieces. Now they don't use the word divide, but that is another way to say we're going to cut this into 7 pieces. So that tells us we need to divide 147 divided by 7. Now again, when you cut something, you're going to have a little bit of waste, but they're telling us that we don't have to worry about the waste this time. So we just do 147 divided by 7. So each piece is going to be 21 inches long. Example 8. A family wants to replace their old oil-fired boiler with an air source heat pump or ASHP system. The initial cost of the ASHP system is $4,500, but it will save the family $30 per month in heating and cooling costs. Determine the payback time both in months and in years and months. So what we're going to do is we're going to have this $4,500 and we're going to divide that by 30. So $4,500 divided by 30 is going to be 150 months. So now we're going to have to take our 150 months, divide that by 12 to get the number of years, which turns out to be 12.5. So it's 12 full years, okay? But this 0.5 has to be multiplied by 12 to get 6 months. Because 0.5 or half of, think of 0.5 as a half. 0.5 is a half. It's also 50%, and half of a year is 6 months. So the payback time is 12 years and 6 months. Example 9. For working on remote construction sites, a construction company needs a generator that can supply 1,300 watt circular saw, a 1,700 watt table saw, a 600 watt hand drill, and a 100 watt radio, all simultaneously. What is the total wattage that the generator needs to supply all of these tools? So in other words, on a work site, you've got to make sure if you have no electricity, you're running a generator that is large enough to handle all of your tools. So we need the total, and in this case, we're going to need to add. So my operations are to add these numbers. This is one I could do pretty easily without a calculator, but I'll just add those. 1,300 plus 1,700 plus 600 plus 100 is 3,700 watts. So you would have to make sure that you purchase a generator that is large enough to supply at least 3,700 watts. A master mason is constructing a wall. From similar jobs, he estimates that he can lay an average of 120 bricks an hour. How long will it take him to lay 5,760 bricks? So if we have to divide our time to lay 5,760 bricks, we're going to have to divide by the number of bricks we can do in an hour. So we will divide this 5,760 divided by 120, and we get 48 hours. It will take the bricklayer 48 hours to lay the 5,760 bricks. Now, again, if you're not sure which operation, think about an hour. They could have said per hour. And we said that per hour would be either multiply or divide. If we multiplied that, 5,760 times 120, we get 691,000 hours. Now that doesn't make any sense. So think about your word clues and also think about your answer and whether or not it makes sense in the context.